Okay, today we're going to spend another day factoring polynomials, and I want to go right to this idea of doing backwards FOIL. You know there's another method, the grouping method. I think some of you have called it the factor sum method. But sometimes it's just more efficient to do backwards FOIL. Let me show you what I mean. If I'm asked to factor x squared minus 7x plus 12, this is where the leading coefficient is 1. Okay, when the number in front of x right here is a 1. I think it's easier to do backwards FOIL. Let's think of this. What do I multiply to get x squared? Isn't it x and x? What do I multiply to get 12 that adds up to be 7? 3 and 4. Right? And then, since this is a plus, and this is a minus, don't these both have to have the same sign? Right? Now, how can you check your answer? Do FOIL. And can't we do that mentally as well? But, we'll just kind of write it out here. X squared minus 4x minus 3x plus 12. Doesn't that make this? Right? So we have factored it. And I think it's much quicker to use backwards FOIL in that situation. All right? So this right here is my answer. Let's do another one of those. How about x squared minus x minus 72? Well, let's think of this. Go ahead and set up your parentheses. I would go ahead and put x and x, since my leading coefficient is 1. Now, this time I have a negative 72. So doesn't that mean one of these has to be a positive, the other one has to be a negative? Right? Now, I need two numbers this time that multiply to get 72, but have a difference of 1. 9 and 8, isn't it? Now, where do I put them, though? Well, right, I want the 8 here and the 9 here. That way, when I think outside, I get a negative 9, right? Plus 8, negative 9x plus 8x will give me that negative 1 in the middle. So I think sometimes it's more efficient to do backwards FOIL. All right? That's kind of the way I see it. But sometimes, as you know, we want to factor by grouping. And I think, I don't remember what you guys called this last year. I think maybe factor sum, product sum. Okay, that may be what you called it. So let's just get right to an example here. If I have 2x squared plus x minus 15, and I'm just going to kind of walk you through the steps, all right, because you might be a little bit rusty with it. Step 1. Our first step is to multiply the a term times the c term. Okay, 2 times negative 15. And we get negative 30. That's step 1. Step 2 is I want factors that will multiply to give me negative 30, but will add up to be the b term. What is this b term right here? Isn't it 1? So I need two numbers that will multiply to give me negative 30. Isn't it going to be 6 and 5? But which one's positive, which one's negative? The 6 is positive, the 5 is negative. Now what those two numbers are my two middle terms. So now step 3 is to rewrite this polynomial as 2x squared plus 6x minus 5x minus 15. Okay, I keep the a and the c terms and I rewrite the middle. Now we do what's called factoring by grouping. So I am now going to break this up into two little pieces here, and I'm going to take out what's common to both. In the first one, I'm going to take out a 2x, and I will be left with an x plus 3. On the next one, I'm going to take out a negative 5, and I'll be left with an x plus 3. If you do this correctly, you must have these two be the same. Because what we're going to do now is kind of what we did on one of those problems from yesterday. We're going to take out an x plus 3. So that's this step. That's step number 4. I'm going to take out the x plus 3, and I'll be left with 2x minus 5. And now the problem is done. The product sum method is, I think, maybe the most advantageous or the best way to do it when this leading coefficient is not 1. Okay, I just think it'll save you some heartache, all right, to do it this way. Let's do another one. And I'm going to let you, actually, no, let's not do an easy one. Let's just do another one. Let's do a harder one, like this one. 12x squared minus 5x minus 28. Sometimes they're bigger, uglier numbers. Well, we still do the same thing. Okay, we're going to multiply a times c. 12 times negative 28. And of course, it's good to maybe use the calculator a little bit to help you. This is negative 336. Now, the next step 2 on this one is the hardest part, because I need to come up with two numbers that multiply to give me negative 36, but have a difference of negative 5. All right? Now, doesn't that mean they have to be somewhat close together? So, you know, if you start playing with your calculator, just pick two numbers that are 5 apart, right? So, you know, maybe you try 15 times 10. You know, if I do 15 times 10, I get 150. That's not going to work because that's nowhere near 336. So don't I need it to be much bigger? Yeah, so maybe I do 20 times 15. How about 20 times 15? Well, that gives me 300. I'm still not there, right? So maybe I do 21 times 16. So 21 times 16, that works, right? Do you see how I did that? I started working with numbers that were 5 apart, and then I just kept going up until I got to 336. This one is 336. Since this thing is negative, I need it to be negative 21 and positive 16. And then from there on, isn't it the same process? I'm not going to finish this one all the way. Your next step would be 12x squared minus 21x plus 16x minus 28. And I think you would be good from that point on. Okay? So the hard part there is finding the two numbers. Okay? Now, sometimes they're going to say factor completely. Factor completely. And this is where you kind of have to put a couple of skills together. Let me show you what I mean. We actually tackled one like this, a little bit like this yesterday. 8x squared minus 200. Now right away, do you see that it's only 2 terms instead of 3? It's only 2 terms. So if it's only two terms, you can't do the product sum method. And you can't do backwards FOIL. You need to be thinking, is this a difference of two squares? Well, 8's not a perfect square, and 200 is not a perfect square. So then we think, can I take something out of both? Is there an 8 in both? There is. Aren't there 8 quarters and $2? Right? So if I take an 8 out, I'm left with x squared minus 25. Okay, there's 8 quarters and $2. So that works. Now is it a difference of two squares? Yes, it is. So now I can make it 8 times x plus 5 times x minus 5. So don't forget, if you're hung up on a problem that just won't work, when you just have two terms like this one, try taking out something common to both first. Let's do another one like that. 2y cubed minus y squared minus 28y. Now this one has three terms. All right, it does have three terms, so we might be thinking, well, can I do backwards FOIL or can I do the product sum method? Not yet, because I've got this cubed term here. So, yes, we want to take a y out of all three terms. If I take a y out, I'm left with 2y squared minus y minus 28. And now you can do the product sum method. Let's see if we can do that a little bit quicker this time. 2 times negative 28 is negative 56. I need two numbers that have a difference of negative 1, so that's going to be negative 8, positive 7. So this will be 2y squared minus 8y plus 7y minus 28. Take out a 2y. I'm left with y minus 4. Here I need to take out a negative 7, so I'm left with a y minus 4. So I pull out a y minus 4 times 2y minus 7, and then I have a y there. Okay? Okay, I saw this mistake here. This was a negative 28, so this should have been a positive 7 here. Okay, so this is your final answer on that problem. And we will stop there for today.